Hello, Keith Rucker at VintageMachinery.org. Well guys, we're back on making our gears, and we're about ready now to actually get over here and get the milling machine set up to start cutting some gear teeth. And I've already got my dividing head mounted up here on the mill, and we're going to go over basically how to get the milling machine set up to do gear cutting, and then go through the practice of cutting 2 gears on the horizontal mill. Let's get going. What we're going to use to actually make the divisions to make these cuts on this horizontal mill is this dividing head. And this dividing head does just that. It divides something up into a certain number of divisions that you want on here. And there's a couple of different flavors of dividing heads out there. They basically fall into 2 camps. They all do basically the same thing, but what's different from one to another is the ratio. So if you look here, I got this handle, and when I turn this handle, you see that the chuck is turning here. This particular dividing head has a ratio of 40 to 1. So I have to crank this handle 40 times to make the chuck here revolve 1 time. Now some dividing heads have a 5 to 1 ratio. The 40 to 1 seems to be more common, but both of those are out there. And what you have to do is you have to figure out how many turns you need to do for your dividing head. Now there's some charts online that you can look these up on. If you have the instructions for your dividing head, it should have a chart. So if you wanted to cut a 12 tooth gear, as we're going to be doing, you can look on there and it will tell you which plates you use, which bolt holes or which hole circle you need to use, and how many divisions. Now there's these plates that go on here, and there are multiple plates. I think K&T has 6 different plates with different hole arrangements in it. This one here, let's see, we got a 15, a 16, 17, 18, 19, and 20. So that's the number of holes in that division are in there. And I know from looking on my chart that I'm in the 18 ring, and to do 12 divisions, what I have to do is I have to do 3 full revolutions, and then 6 holes on that 18 ring. So I have this little sector in here set to help me so that I can really quickly find that 6th hole. 1, 2, 3, and then go over here to your next hole. Now, one thing I will caution here is there is a little bit of backlash. There's not much. You should always go into this thing moving forward. If for some reason you go past your hole, come back out and then come back into it. Don't just go straight into it, because you could have just a little bit of backlash in your dividing head. But anyway, that's basically what we're going to be doing here today, is using this dividing head to make these divisions. Now, as for my part, this dividing head has a chuck on them. Some of them have a center in it where you can do it between centers. I actually prefer that method, but I don't really have a good center in here, except that I chuck up in the chuck. So instead of putting a center in the chuck, and if the chuck's out a little bit, my center will be out, I'm just going to chuck the part directly in here. And we'll just go ahead and tighten that down. Let me pull my part there around where I can tighten that up, get that up on the top side. And another thing I like here, if you're doing between centers, you're automatically going to be pushing against the center, and really it can't go any farther past that. In this case, I've got a little shoulder here. I'm going to put that up against the chuck, so that as this is cutting, it's going to be cutting in this direction. So it's impossible for it to push into the chuck. We do that, and then I got my little foot stock here, and we'll pull that up in there and have it running between. I'll center on this end just to give it some more support. So now my part's in here. I know my divisions. I got my plate set here, and this is ready to go. And I've already actually come in here and I've done the whole cycle around. I count the number of dots on there just to double check to make sure I'm getting 12 divisions, and I am. So now we need to get our cutter set up to make the cut. Now the cutter that I'm going to use is going to fit onto a horizontal shaft here. It's going to be true horizontal milling. So I've got an arbor here. This is a 1-inch arbor. So basically it will take a 1-inch diameter, inside diameter cutter I'm going to just start by wiping out my 50 taper, wiping out the spindle that goes on here, and we'll go ahead and install the shaft in here, and I will tighten it up on the back side. The Arbor here has bushings on it. They're just basically just little spacers that fit up on here to position your cutter where you want. I also have a keyway in here, and that's going to drive my cutter. And I'm pretty much to the point here where I'm ready to put my cutter on. And it's real important when you're cutting gears to make sure you have the right cutter. And there's a couple of things you need to look at. Number one is, what diametral pitch are you doing? I know from testing these, this is a 14 diametral pitch. So I have a DP 14 cutter, okay? I also need to know my pressure angle. I know that we're doing 14.5 on these. So I have a cutter that is a 14.5 pressure angle. The other common size is 20 degree pressure angle, although 14.5 seems to be generally the most common type. And for each pitch and for each pitch and pressure angle, so for 14 deep diametral pitch, 14.5 pressure angle, there are 8 different cutters that you can potentially use on the Involute series, depending on the number of teeth that you're cutting. And again, you need to go look at a chart. It's usually on, very often it's on the cutter here, how many teeth you can cut on that particular one. Sometimes it just gives a number. I know that we're doing 12 teeth on this, and looking in my machinery's handbook, I know I need cutter number 8, and this one says number 8. Sometimes it will actually it says right here that's for 12 or 13 teeth. So the number 8 is only used for 12 teeth and 13 teeth. So I got the right cutter. The cutter's going to be turning in this direction, cutting in toward the dividing head. So I'll make sure I position it on there correctly. And we will go ahead and put that on there. And we'll build the rest of this out, just putting spacers on here to get us out toward the end here a little bit farther. And then I'm going to put my bushing on here. This is basically just a bearing. There's going to be a overarm support that goes up on there, and this larger one here will be the bearing surface and the nut. And I'm not going to tighten the nut down right now. You always want to tighten the nut when you have it supported, because if you come out here right now and put a big crescent wrench on this thing, go yanking on it, with it sticking out, you can very easily bend this arbor. We wanted this arbor to run true, so we'll wait till we get the overarm support on. And with that, I'm going to go grab the overarm support, and I will get it put on here. I've got my overarm support here sitting on the end of the table, and I've already come in here and just taken a rag and cleaned up all the bearing surfaces on the inside. This has been sitting for a while, and it's gotten kind of gritty and greasy. Next thing I'm going to do is I'm going to extend my overarm supports out here, and there's just a little hand wheel on the end. I'm going to go all the way out past the end of the arbor. I find it easier when I'm putting this thing on, instead of trying to line it up on all 3 bearing surfaces at one time, just get it on the arm first. So we'll just slide it up here on the arm. Let me grab a wrench and tighten that down. Okay, that is locked down now on the overarms. And now what I'll do is I'll use my little lever back there, and we'll pull it up over and onto the bushing. I just find that makes alignment go a lot easier. It just goes right up on there. And there we go. Tell you what, I'm going to push it out just a touch. Yeah, that's fine right about there. And then the next thing I'm going to do is there's a couple of bolts on the top, and that's going to lock these overarms so they can't move in and out. So we'll go ahead and tighten these down as well. I got you zoomed in here because I want to show you how I'm going to get this cutter now centered up onto the shaft here. And I don't know if it's going to show up in the video or not very well, but basically what I did was I just eyeballed a center on this, and I lowered or raised the table, I guess, up into the cutter here. until it was just barely touching the top. And when I did that, I then moved the table side to side, just swept across it. And what that does is it marks clearly across the top there the center. Basically, the lowest point of the cutter is hitting the highest point of the part. I moved side to side, across it, swept it, and it left a little mark right there in the very center of this shaft. And now some people don't like the way I do this, but this is the way I was taught. This is what's always worked for me. From there, I can easily go in here and just look down this thing and line the center of the cutter up with that mark. And it's that simple. No measurements, no nothing. Your eye is actually a very good measuring device. Use it to your advantage. And in this situation like this, I'm going to have that plenty good enough on center for this gear. So anyway, that's how I did it. That's how a lot of old timers do it. And that's the way that I'm going to do it here. So the other thing that this has done now is I'm marked on 0 on my height here. So I know that that's 0, and we'll back off of that now, and we'll know how far we need to raise the table up in there to make our cuts to get all this to the proper depth. So I'm going to show you this little sheet that I created. I actually created a little Excel spreadsheet that will do a lot of my calculations for me when I'm doing gear cutting. And I know I've had some people in the past ask if I would share this spreadsheet, and I'm not against doing that, but right now the spreadsheet is not really exactly finished yet. Basically, I'm having to go in and manually put some factors in here, basically going information out of the machinery's handbook to do this. And I'm trying to get this where it's completely automated, where you don't have to go look anything up and there's no manual input, where basically all you'll have to do is put in your diametral pitch, your number of your teeth, and your pressure angle, and it will calculate everything for you. If I ever get that done, I'll be glad to share this. But right now, it's too much user input to be useful to the general public. But anyway, I've got this, and this tells me all my critical measurements, everything I need to know to come over here and cut these teeth. And it also tells me how to, when I'm doing checking it, using either measuring over pins, which is a good way to, and that's one method we'll do, or using a gear caliper. I usually use both to double check my work. But right now, what I'm looking at on here, again, a diametral pitch is 14, number of teeth is 12. It's a 14.5 degree pressure angle. It tells me I need to use cutter number 8 out of that set. It tells me, it automatically calculates the outside diameter of what that gear should be, which is 1 inch. We already knew that. A lot of other stuff in here that's really not super important unless you're really doing a lot of measurements. The big thing I want to do is look at here, depth of cut to obtain backlash. And backlash is something that you have to factor in these gears. I mean, you can make a gear that is perfectly meshed, but you want to have just a little bit of play in there so that things don't bind up. And the spreadsheet actually calculates what the backlash should be for an average situation, 3/1000ths backlash in this particular case. And then it tells me my depth of cut that I need to make to put that backlash factor in there. That's the number I'm interested in right now. 157 thousandths deep is what I want to go. I think what I'm going to do is we're going to do this in 2 passes. I'm going to do a 100 thousandths deep cut, and then we're going to go in here, we'll measure everything over the pins. That will give me a more accurate measurement to dial into for the next cut, and then we'll check it again, and if necessary, make a third. Usually 2 cuts is all I need to do. I can dial it in. But 157, I'm going to go 100 right now. Tell you what, I'm going to go 125. That'll still give me enough to clean up on the last pass, and my machine will easily take 125. So I'm going to dial in that 125 now. And to do that, I'm using a dial indicator to tell me how far I've moved. We're on 0 right now. I'm going to bring my table up 125. Actually, I'm going to back off of that just a little bit because I'm going to lock my table. And when I do, it usually All right. Brings that measurement up just a little bit. There we go, 125. I've got my height locked. I've got my table lock going in this direction. The only way it can move now is going in and out. We're going to take 125 thousandths off of each side, and that should leave us about 27 thousandths that we'll have to come in and clean up on the next pass. We're ready to make our first cut now, I think. A little bit about feeds and speeds. I've got the machine set up right now. We're cutting 119 revolutions per minute. And as far as feeds go, I may play around with my feeds. Right now we're on 2 1/8 inches per minute. Put a little cutting oil in here, and we'll start feeding our table in. See how she sounds. You hear that kind of bump, bump, bump sound? That's pretty typical on a horizontal mill. These cutters rarely run perfectly true, but as it's cutting, one tooth is probably cutting a little bit more than others, but it's getting the full depth. All right, we're through cutting. Pull my cutter back out. So I'll loosen my lock on the dividing head. Remember, we're doing 3 turns and then 6 indexes. So I go 1, 2, 3 over here. We'll lock it back down, and now we're ready for our second pass. Put a little oil in here, and we're ready for our second pass. we've got our first pass done here. The gear is looking great. You can tell it's not to depth yet, but like we said, we wanted to cut it a little bit shallow and then come back in and clean it up on another pass. So now I need to measure this to see exactly how much we need to take out. And the way we're going to do that is I'm going to pull my little cheat sheet back up here again, and we're going to use a method called measuring over pins. So if you look here, you can see there's a pin there and a pin there 180 degrees apart from one another. And we're going to basically measure across those pins. Now my little calculator spreadsheet that I've got here, it will tell you what size pin you need to use. In this case, for this gear pitch, you need to use one that's 120 thousandths in diameter. So I actually have cut 14 pitch gears before, so I purchased some time back 2 gauge pins that are 120 thousandths. So I got 2 perfectly 120 thousandths gauge pins. I'm going to put them across from one another, and we're going to measure across that distance. And down here it tells me what that measurement should be. So just normally it should be 1 inch 13 thousandths, but when you calculate in the backlash, again, we want to have 3 thousandths backlash in there. It needs to measure 1 inch 1,000th over an inch. So let me get in here and measure it and see where we're at, and then we'll know how deep we need to go. So here are my 2 gauge pins, and I know you can't see that, but I can see 120 thousandths for both of those. What I'm going to do is we will put these on here directly across from one another. Tell you what, I'm going to measure like that instead of going straight up and down. This is when you need a third hand sometimes. But I'm going to come in here with my micrometer now, and we'll get a good measurement right across those pins. All right, so we are at 50 plus 21 would be 71 thousandths. So we're 1 inch 71 thousandths. Okay, we need to be at 1 inch 1,000, so I'll subtract 1,000 from that, so that gives me 70 thousandths over. And remember, that's on both sides, so I need to bring in half of that amount on each side. So we need to come in 35 thousandths more in depth, and that should get us right on the money. So I'm just going to go ahead, we'll dial in another 35 thousandths, and we should be finished with this. So now we're going to raise our table. I've got it zeroed now. I'm going to release the lock, and it's going to probably move just a little bit. That's fine. We're going to go off of the locked position to raise it up. So there's 30. I think that's going to be good enough right there. 35 thousandths, maybe off by a tenth or two, but it's not going to matter. We're good. Let's go ahead. We'll make another pass through here. Cut the rest of those teeth. Let's cut them away. Okay, I've got my pins back out here. I'm going to go in again, measure across both of those. We're shooting for 1 inch 1,000ths, and I don't know if you can see that or not. Let's see. Right there. 1,000ths over 1 inch. Dead on the money. So that gear should be just right. So we're ready to press this together now. So I've got my piece. I need to put my little keyway in here. I'm just going to take a little hammer. Tap that in there. And we're going to press this in. But before I do, you know, just to be on the safe side, I'm going to put a little Loctite on this to just to make sure it doesn't come through. It's a press fit, so it should be fine. I'm just gonna put a little light layer all the way around this. And it's a nice press fit. It's not too tight, but it's tight enough that it shouldn't come apart. And the gear is now set on there. So we're set up now to do the 40-tooth gear. I've got this set up in the dividing head. We just flipped it around so that it's chucked up on the small end, and we got the big gear exposed here. I don't have to worry about centering it on the shaft because we did that previously. The setup hasn't changed. Center line is still exactly the same. And I've already touched off on the top here to get my 0 on my depth. And now we'll go ahead and move the table to make that first cut. I've zeroed my indicator, and just like before, I want to move up for this first cut, 125 thousandths. So just go ahead and dial it in there. We'll go 100 right there, and then up to 25, which is right there. And I'm not going to get too fidgety with this because we're going to be making a measurement and coming back and making a final cut. You know, we're within probably 3/10, but hey, again, I'm worried about that on the second pass. This is just a rough cut, and we are ready now to start cutting. So as far as the dividing head goes, this is a 40-tooth gear, and with the 40-tooth gear, and this being a 40-to-1 ratio dividing head, this is about as easy of a gear that you can cut, because basically every time I turn this knob around, 40-to-1 is going to be 1/40th. That's the ratio we're looking for. So we're just going to be going back to the same pin, doing one revolution back into the same pin each time. Really, really easy. I've got my sector over here, basically, where I can come around to that, and it will tell me which one to go into. We won't be using the other side of the sector on this one. So now we are definitely ready to start cutting. Let's make a pass and see how it goes. My feeds and speeds on the last one worked out pretty good, so I think we're just going to stick with that and try it on this gear as well. So we'll come in here and let's see how she sounds. We're cutting cast iron this time. I'm probably not going to use any lubrication. People ask me about that all the time, and the fine powder that you get off the cast iron, it just makes for an abrasive when it gets mixed with oil, and cast iron has graphite in it. It's kind of self-lubricating. I typically don't use a lot of lubrication when I'm cutting cast iron. All right, let's make a rev here, 1/40th, lock our dividing head, and make the next pass. So we got our first pass on the gear done. Looks great. One thing I want to mention, because I forgot to mention this a while ago when we started cutting this, and I thought about it halfway through the job, but we did change the cutter for this. So on the first pass, we were using a number 8 cutter. For this 40 tooth, we needed to use a number 3 cutter. So even though it's the same diametral pitch, the geometry of the cutter is a little bit different because of the angles on the gear itself. So anyway, we use a number 3, which is the correct one to do that. And now we're going to come in here and once again measure across pins. I'll put a pin on the very top, and we want to get straight across from it. I'm going to come in here with my micrometer and get a good measurement across these. All right, that feels good right there. So pull that out. And we're basically on, I see that's 16 plus 50, so that'd be 66. So that'd be 3 inches and 066, 3.066. We're shooting, according to our spreadsheet, 3.006. So I'm going to subtract the 6 from that. That gives me 60 thousandths total depth that I need to go down. And again, we need to do half of that, so we'll do 30. So I need to pull my mill down 30 thousandths, and we'll make another pass on this, and we should be dead on. All right, just ready for second pass here. I've just marked my first tooth here so that when I come back around, I'll know when I've finished. It's a little bit harder to tell when you're doing these cleanup passes. So anyway, we'll feed in and take our first pass out of there. Last one. We should have this gear cut. Our target was 3 inches and 6 thousandths. If you look on my scale there, I'm about a half a thou over 6. So we're going to call that good enough. With the backlash allowment that was put into this, that half thousandth isn't going to matter for anything in the world. So anyway, we're good. We'll go ahead and take this out. Here we go, our finished gear set. All looks great to me. Hopefully this will fit right in and be able to put right to use. So it looks good. I'm happy with my work. Well, there you go, one more project knocked out. So we got this little gear set all made up for Laddie, and we're gonna get this back in the mail to him so he can get it reinstalled back in his Reed-Prentice lathe and hopefully get that machine saved from the scrap yards and back into action. So anyway, I always enjoy doing these gear jobs. It's just fun to do, and it's just really neat to be able to start with a couple pieces of round metal and come out with a fairly intricate precision machined piece such as this. So anyway, lots of fun. I hope you enjoyed it as well. And if you did, please leave me a thumbs up, leave me some comments. If you haven't already, please subscribe to the channel. You'll get to see some more content coming your way. Machine shop, workshop related stuff. And with that, we'll sign off. Thanks as always for watching. We'll talk to you later.